Hello guys, welcome to my YouTube channel. Today we are going to discuss about one of the famous searching techniques, that is binary search. Have you ever wondered what is binary search and how the binary search works? Yes, this video is for you. So in order to explain about the binary search, first we need to understand what's the problem statement. So we are taking an example of an array that consists of 5 elements 1, 2, 3, 4, 5, and the problem statement states that you need to find out you will be having a target element. You need to find out whether the element is present in the array or not. For example, if your target is 5, you should search whether this 5 is present inside the array or not. Or let's say your target is 4, whether you can say whether the 4 is present in the array or not. Let's say your target is 7, then you can say my target is not present in the 7. So uh, you need to return whether that number that you are looking for is present in the array or not. So let's consider the number that has to be searched. It has to be find out is 4. So how can we find out whether the number 4 is present in the array or not? One technique that we can use is linear search. Uh, linear search is nothing but you will be having a pointer and you will be initializing that pointer towards the first element of the array. Here the first element of our array is 1, and in you will find you will compare whether the first element that we are looking for is our target or not. Here 1 is not our target, so then our pointer moves towards 2, and it will check whether the 4 is equivalent to 2 or not. Like this, the pointer will traverse uh, towards the end of the array and try to find out whether the element which we are looking for is present in the array or not. So in our case, the number we are looking for is 4. So the pointer goes till 4, 1, 2, 3, and 4, and here it will detect the number which we are looking is present in the array. In this case, this will return that 4 is present in the array or not. So how we can do this? How we can implement this linear search? We can implement this linear search using a simple for loop, and inside the for loop we can use compare operations, and we can detect whether the element which you are looking for is present in the array or not. But the problem arises, and the problem arises uh, time complexity. The time complexity of the linear search that just we discussed now is big O of n, where n is the number of elements inside the array. Uh, uh, why why we got the time complexity as big O of n? Because here we are searching from first element to last element. N means the nth, the last element. So we need to compare all the elements in the array. Even though our the number which we're looking for present in the first position, we need to compare everything. Like you need to compare from first to last. So this gives us a huge time complexity. So in order to eliminate this kind of time complexity, we will use a technique called binary search. Here the time complexity of binary search is log n, which is much smaller than big O of n. So let's see how we can uh, how we can implement binary search. First, we'll talk about the logic, and then we'll talk about the code. So let's take the same example. The array we need to search is 3, 4, and 5. Sorry, the number we need to search is 4. So let's try to look the code first. So here you can see we are having a function called of binary search, and we are having array, the first element, the last element, and the key means the target, the 4 we need to search. So first, what happens is uh, here we will find out the middle element of the array. So what is the element of the array in the present in the middle of the array? So let's say if we are finding out the middle of the array. So the middle of the array is 3. How we can find out the middle of the array is we are having the first element and the last element. So first the pointer is pointing towards 0, the first element, and the pointer is pointing towards n. So 0 plus n divided by 2, which gives the mid element, that is 3. So after finding out the 3, we will see whether our element is that we are searching for is present in the right side of the 3 or in the left side of the 3. Here in this case, the number which we are searching is present in the right side of the 3. That means that the number we are searching is greater than 3. So let's think of a simple logic. We got to know that the array, that the number we need to search is present in the right side, that is 3 is greater than 4. So let's think whether we know that 3 is greater than 4 is greater than 3. So we can say that this part of array is not required, like 1 2 is not required, because we know the element is present somewhere here in this side. So we will eliminate all this side. So element so we don't want any element that is present beside the mid element. So we will divide the array. And we can produce a new array. Here now the new array that we got is 4 and 5. Now we need to again do the same operation that we did for the previous step. So here the new arrays, just a minute. The new array is 4 and 5. Now we need to find out the same. Now we need to apply the same kind of operation. Here we need to find out the mid element of the array. Since we are having only 2 elements, the mid will be pointing towards 4. So here we got to know that in this step we got to know that the element which we are searching for is present in the right side. But here we came to know that the mid element is only the element that we are searching for. Hence we got our answer. So let's try to change it. Let's say the number which we are searching for is 1. At such time, what we were doing, like let's say we have 1 2 3 4 5 and the mid is 3. In the previous case, the number which we were searching for is 4, which was present in the right side. But here the number which we were searching is present in the left side. Means it is lesser than 3. 1 is lesser than 3. So we only want this part of the array. So the new array becomes 1 and 2. So I think you are all getting my point. We will divide the array into 2 parts, and we will take which part is necessary for our further computations. Means we divided the array into 1 2 and 4 5, and we are taking 1 2 or 3 5 based on the number to be searched. So here the new array is 1 and 2, and the mid of the new array is 1. So and this operation will take place again. This will do in iterative steps, and we are finding out the middle of the element of this newly formed array, and the middle of the element is 1, and the number we are looking for is 1, and the number which we are looking for is 1. And so we can say that we have found the answer. So we will return 1. So this is all about the binary search. Let's say we have an element called let's say we have an element called 7. We know that 7 is not present in the array. At such time, uh, the array will, as you know, 7 is greater than 3. The array will reduce, the subarray that we will get is 4 and 5. And here, in this, we again make the partition, and the array becomes 5. And in 5 also we are not getting the 7. So we can say that 7 is not present in the array. But here, 1 and 4 is present in the array. So that's how we can calculate the element which is present in the array or not. So this is the approach of binary search, and the time complexity is log n, because we are dividing the array, we are dividing and rolling it. We are dividing the array and we are taking only the array which we wanted. So the time complexity get reduced and it will become big of log n. Let's try to understand the code part of it. As I told, here we are finding out the mid first. We're finding out the mid first here. As you know, the mid in our element was 3, and we are like, as I told, we need to do recursively until the element is found or element is not found. So we are initializing a while loop, and the while loop, you all know the while loop uh, runs until uh, uh, the condition become false. Here we can we know that first is lesser than last, and the first if else states that, first if else states that if array of mid is lesser than key, then we need to move the pointer towards mid plus 1. Uh, as I explained, the element which we are looking is 4, but the mid element we got is 3. So we need to take only 4 and 5. So we'll move the pointer towards 4. Now the first pointer will be pointing towards 4, and the last pointer will be pointing towards 5. So what it's stating is, uh, the element between the first and last pointer is our array. Like the new array that we got will go from first to last. So this is the condition when the element is lesser than the target element is lesser than the mid, and this is the other condition when this is the other condition when element is greater than or lesser than array, and this is the condition when we find our answer. So we can say the element is found at the position mid, so print this. So yeah, so this is the example for 3 and 1. So let's talk about the example that I took in the last 7. That is, what if the in the case, what to do in the case when the element which we're looking for is not present in the array. So at such time, obviously the first will become greater than last. At the time we can print the element is not found. We are not able to find the element which we are searching for. So I think you all got to know that how this function works. So in the main function, how this works is, we are declaring an array. We are searching the element which we wanted. In this case is 30, and we are finding out, and we are calling the binary search function, and we are returning the element that is found. So this is all about the binary search video. I hope you all understood the logic. Thank you. For more updates like this, please subscribe Code Clashers and hit the like button.